Hello and welcome to this video reviewing quadratic equations. So in this video we're going to be looking at a number of different questions. Some of them we're going to do, and then some of them I'm going to skip past, and then you can work on those on your own. So the first one there, number 1, it says use the graph to state the roots of each equation. So we have our graph here, it's already plotted for us, and I can see the roots, and remember roots, those are just x-intercepts, so let's write that. So roots, they can be called x-intercepts, zeros, or solutions, those all mean the same thing, and I can see the two right here on my graph, so I can see the one is at -1, so I'm going to write x is equal to -1. And then the other one there was at 5, so x equals 5. And those are your two solutions. For part B here, you can work on that on your own. I'm going to skip by, go to number 2. And in number 2, it says, explain which properties dictate the number of x-intercepts for each of the following. Then sketch a sample of each type of graph on the same set of axes. So in the first one, part A, two distinct real roots. So if you have two distinct real roots, we said those are the same as x-intercepts, so that means you're going to have two x-intercepts. So therefore, two x-intercepts. And then if I were to graph something like that, there's a bunch of different graphs that we could draw, but I'll just draw one like that, and I can see it's got 1, 2 x-intercepts, so that has two distinct real roots. For part B, one real root, that tells us it's therefore going to have one x-intercept. So drawing a graph where it has only one x-intercept, I'll draw it like this. And again, they could point up or down. It's just the number of x-intercepts that matters. So in this case, it crosses just once there, just touches perfectly. And for part C, the last one, for no real roots, that is when you're then going to have no x-intercepts, so therefore no x-intercepts. And the graph for that one, I'm going to draw pointing down. With that one, it just can't have any part of the graph crossing the x-axis, so it's got 0 x-intercepts, 0 real roots. On to number 3 of the next page, we are going to look at A. So it says, graph the following from your graph, state the roots to the nearest 10th. So first I'm going to start by drawing my axes on my graph. And then I am going to label some points on there. So now that I have some points on my graph, I'm going to go to my calculator here, and I'm going to put in this function to help get some points. So we're going to go to y equals and then type this in. And then to see our graph, just click the graph button. So there's our graph, and we're going to find these two x-intercepts. So those occur at a height of 0. So we are going to go second trace, and then we're going to use the 0 function. That's going to find when it's at a height of 0, which are our x-intercepts. So I'm going to scroll over until I get to the point. And then we got to do the left bound and the right bound of this. So get on the left side, that is, if I went to the left of this point, that's back this way, click enter. And then right bound, you got to go back to the point and then click to the right of it, click enter. And then it's going to search in between those points and find our x-intercept. So when we do that, we get 2.76 and then some more decimals. And then we're going to find our other one over here. So we'll do the same process, second calc. Option number 2, that's our 0, and then scroll all the way over to our point. So it's right there, and then go to the left, enter, right, enter. It's going to search in between there, enter one more time, and we get 7.236. We can also, to find another point, we can find the vertex. So to do that, that's the minimum point. So we'll go second calc, and we'll find the minimum, so that's number 3. And scroll all the way to the vertex. And again, it's asking for the left bound, so scroll to the left, click enter, and then it asks for the right bound, so go back to the vertex, and then somewhere to the right, enter, and then one more time for it to find the vertex. So that's at 4.9999. If we'd round that, it's at 5. So it's at 5 and -5. So I'm going to write that information just over here, and then we're going to graph that. So plotting those points, I had the vertex at 5 and -5. So here's 5, and then I'm going to go down to -5. So that is right there. Our one x-intercept, or one root, was at 2.76. So right there is 3. So we are about 3/4 of the way to there. And then 7.23 here is 7. And then we're about 1/4 of the way to 8. So there are our points, and then we can just draw our parabola going through our points, and then just make sure you draw arrows on the end to signify that this just keeps going upwards. So we're done with that one. B and C, you can do that one on your own. Looking at question number 4, we are going to do B here together. So in these ones, it says factor each of the following completely. Now, whenever you see something like this, where you have, say, x minus 6 and then another x minus 6, what you want to do is you want to use a substitution to make this easier. So I'm going to say, let y equal x minus 6, and then I'm going to substitute that in. So instead now I have y squared instead of x minus 6 squared plus 10 times the x minus 6, it changes into a y, and then plus 9. So this is a lot simpler. This I can factor a lot easier. I just got to remember to substitute back in this at the very end. So to factor that, we can use our product sum method. So the product is 9 and the sum is 10. And then the two numbers that are going to do that are a 9 and a 1. So 9 and 1. And then it's going to split into those two numbers. So we got y plus 9 and y plus 1. And then again, we got to resubstitute this back in. So y is actually equal to x minus 6. So y is changing back into x minus 6. And then here we have x minus 6 again. And then don't forget the plus 1. And then I'm just going to simplify that. So I can put the two numbers together in each of these brackets. So in the first one, I'm going to have x minus 15. And then in the second one, I'm going to have x minus 5. And then that would be your answer. We're also going to look at question C here. So this one, there's only two terms, 2 terms, and there's a difference in the middle. So when you get that type, you're going to be trying to think that it's a difference of squares. So if you took the square root of that first term, 9m squared over 16, if you take the square root of that, you'd get 3m over 4. And if you took the square root of that second term, 100n squared over 81, take the square root of that, you're going to get 10n over 9. So our difference of squares, you just took the first one here, put that in brackets, and then you took the second one here and put that one in brackets, and then they were just separated by a plus and a minus. So I'm going to have 3m over 4 plus 10n over 9, and then I'm going to have the exact same thing, but there's going to be a minus now in between. So one has a plus and the other one has a minus, and the order of these, it doesn't matter. You could flip it and it would still be the same thing. Moving on into number 5. For that one, it says solve each of the following equations by factoring and then verify your answers. So we're going to do A and B. So anytime you are solving an equation, you want to get everything all over onto one side first. That should be step number 1. And then if we're doing this by factoring, we're going to attempt to factor. So in this case, I can do my product and my sum. So my product is 8, and then my sum is 6. So I've got to multiply to 8 and sum to 6. And the two numbers that do that are 4 and a 2. And then our brackets are going to be x plus a 4 and x plus a 2 equals 0. Don't forget the equal 0. And then we just take each of these and we set them equal to 0. I can just look at that and know what each one is going to be. So we're going to get x equals negative 4 from the first one, and from the second one you'll get negative 2. And then lastly it said to verify, so we're just going to verify our answers here. And to do that, you just take your answers and put them back into the equation that you were given. So I'm going to have negative 4 squared plus 6 times negative 4 plus 8. And when I evaluate that, you can use your calculator to help check, you do get 0, which is what we needed to get. So that one is good. When I do my second one, so it's going to be negative 2 squared plus 6 times negative 2 plus 8. That one you also get 0, so you know that that one is also correct and that is an answer. Looking at part B for this one, now this one's a little harder because the first term there, the 3, it is not a 1. So we can still start by doing our product sum method, but it's going to be a little bit longer. So the product is 3 times 2, so that's going to be a product of 6, and then the sum is negative 5. And then the two numbers that multiply to 6 and sum to negative 5 is a negative 3 and a negative 2. Now the steps that we do next, that would depend on which way you want to do it. I am going to use the factor by grouping method. So you're going to write 3x squared, and then that middle term breaks down into the two numbers that we just got. So minus 3x and a minus 2x. And then we still have that plus 2 equals 0. Then we're going to factor these two as a group. So out of those two, I can pull out a 3 and an x, and I'm left over with an x and a minus 1. Then for the second two, I can only pull a 2 out of those, and if this sign is negative, you want to pull that out. So I'm going to pull out a negative 2, and I'm left with an x minus 1. And then what should happen is you get the exact same thing in brackets, and in this case we do, because now I can pull that out from both sides. So when I pull that out, I got x minus 1 pulled out, and then the 3x and the minus 2, those are the leftovers. So 3x minus 2 go in brackets, and that equals 0. Now I'm going to take each one of these and set them equal to 0 and solve. So this one, x minus 1 equals 0. Add 1 to both sides, so x equals 1. That one's fairly simple. And then you'll take this second one here, 3x minus 2. Set that equal to 0. Add 2 onto both sides, so you get 3x equals 2. And then divide both sides by 3, so you get x equals 2 over 3. So those are our two solutions, and again, to verify your answer, you would just take your two answers and you'll plug them into this, and you should get out a 0. If you don't, that means it's extraneous and you need to get rid of it. So moving from that one, next we're going to look at number 6 here. So 6 says, one side of an envelope is 3 inches longer than the other side. The area of the envelope is 108 inches squared. Determine the dimensions of the envelope, and we want to first start by sketching our diagram in order to help us with this one. So I'm going to sketch my envelope just up top here, and then I'm going to label my sides. So one side was 3 inches longer than the other, so I'm going to say that this side is x, and then this other side is going to be 3 more than that, so it's going to be x plus 3. So I know what my envelope now looks like. The only other piece of information that we had was that the area was 108 inches squared. So I'm going to start with area. I know area of a rectangle is length times width, and then I'm going to fill this in. So my area is 108 inches squared. My length I will say is my x, and then my width I will say is my x plus 3. Make sure you put that in brackets. So now I have a quadratic equation. I'm just going to first start by distributing the x into the brackets here. So I got 108 equals x squared plus 3x. And then we're going to move everything to the same side. I'm just going to bring my work up top here. So I am going to subtract 108 from both sides. Those 108s are going to cancel. And so I'll have 0 equals x squared plus 3x minus 108. And then I can factor that, so I'll do my product and my sum. So my product is negative 108, and my sum is 3. And then the two numbers that do that are a 12 and a -9. So it's just going to break apart into those two factors. So I got x plus a 12 and x minus 9. And then I'll take each of those brackets and set them equal to 0. So I'll take this one, x plus 12 equals 0. Subtract 12 from both sides, and you get x equals -12. And then I'll take this one, x minus 9, set it equal to 0, and then add 9 onto both sides, and you get x equals 9. Now looking at those two answers, x equals -12 and x equals 9, because this was an applied question, we got to think about what we actually found. So if x equals -12, remember x was the length on our envelope, so x can't equal anything negative. So we're going to have to cross that out and say that's extraneous. But the x equals 9 we can have. So I know this one side is 9, and then to find our other dimension here, the width, we're just going to put a 9 in for x, so it's going to be 9 plus 3, and we'll get 12. So our dimensions are going to be 9 by 12. From there, we're going to skip down past number 7. Those ones are a little bit easier. They're kind of related to number 8. So in number 8, it says, solve each of the following by completing the square. State your answers as exact values and as approximations to the nearest tenth. So we are going to do part B together here. Now when I first look at B, I can see that each of these terms is an even number. So what I could do right off the bat, I could divide all of those terms by 2. You even have to divide the 0 here by 2. So all the terms get divided by 2, and we get x squared minus 10x plus 7, and then 0 divided by 2, that's still 0. So the only time you can do this kind of divide or multiply or anything like that is when you have an equation. You can't do that within an expression. There has to be an equal sign somewhere. So now that I have that, this became quite a bit simpler. So to complete the square, I'm going to first take this number here. I'm going to divide that by 2, so 10 divided by 2, and then we're going to square that. So 10 divided by 2 is 5, and squaring it we get 25. So I'm going to add and subtract 25 into this. So I got x squared minus 10x plus 25, and then minus 25 plus 7 equals 0. Now these first three terms, those are a perfect trinomial square, and to factor it, the x comes down, the minus comes down, and then when the 10 comes down, it just gets divided by 2. So we get 5, and then we throw that in brackets and square it. These two numbers here I can put together, so minus 25 plus 7, that is going to equal -18. And then we got equals 0. Now to solve this, I'm just going to bring my work up here. I'm going to start to try to isolate this x. So I got to get rid of the 18, get rid of the square, and then get rid of the -5. So to first get rid of the 18, I'm going to add 18 to both sides. And that'll give me x minus 5 squared equals positive 18 now on the other side. Then we got to get rid of the square, so take the square root. So square root, square and square root cancel. So I got x minus 5 equals, and then the square root of 18 we can just leave as plus or minus square root 18. And then we got to get rid of this minus 5, so add 5 onto both sides, and we get x equals, 5 is now over on this side positive, and then plus or minus square root 18. Now this square root 18, depending on what you know with radicals, you can simplify square root 18. If you haven't done anything with radicals though, you won't know how to do that. So if you did simplify that, you'd get 5 plus or minus, and then 18 you can break down into a 9 times 2, and the square root of 9 is a 3. So a 3 will be able to be brought out, and then that 2 is stuck inside. But if you don't know radicals, you can just ignore that, and this would be your answer. It also asked for it though as approximations to the nearest tenth. So if I took this and put that into my calculator. I'll do one where it's a positive and then one where it's the negative. So for the positive one, you're going to get 9.2426. And then some more decimals. And then if we round that to the nearest tenth, you're going to get 9.2. And then the other answer you're going to get is going to be 0.7573. And this is when you take the negative. And then rounding that to the nearest tenth, you're going to get 0.8. So moving from question number 8 now, we're going to look at question number 10. And here it says, use the discriminant to decide the nature of the roots for each of the following. And we are going to do question A here together. So first what we got to do is we got to get this 8 over to the other side. You always got to have equals 0 on the one side. So when that gets moved over, it's now minus 8. And now I can see my quadratic equation is equal to 0. So our discriminant, if you remember what that was, and it's asking us up here, what is the discriminant? That was equal to b squared minus 4ac. And that's why we had to get this over to the other side, because then I can see my a, my b, and my c. So I'm going to take those numbers and plug that into this. So I'm just going to write it out, b squared minus 4 times a times c. So b squared, that's going to be 5 squared minus 4 times a is a 2, times by c, which is negative 8. And when I calculate that, that's going to be 25 plus 64. And then that is going to equal 89. And 89 is greater than 0. So we had said if the discriminant is positive, which is greater than 0, that meant that there were going to be two real distinct roots. Okay, so for that one we got two distinct real roots. Remember, if your discriminant ever equals 0, that meant you were going to get one real root. And if your discriminant ever was negative, that meant you were going to get no real roots. So you got no solutions. So moving from that one, we're going to do this last question here together, number 11a. So 11 says, use the quadratic formula to solve each of the following. State your answers as exact values and as approximations to the nearest tenth. So again, we got to start with all of the terms being on the same side. So we're going to have to move that 10x over. And when I move it over, it's going to be minus 10x. And then just make sure that you're always writing your terms in order of degree. So highest degree down to lowest degree. X squared, x, no x's. Because now I can see what my a, b, and my c are. The a is the 1 in front of the x squared. The b is the negative 10. And then the c is that last number there, the positive 10. So our quadratic formula is x equals minus b plus or minus the square root of b squared minus 4 times a times c. That's all in a square root. And then all of that is divided by 2 times a. So I'm going to take my numbers that I had just written up top there, and I'm going to put them into this. So it's minus 10, because that b was negative 10. And then we got plus or minus b squared. So that's negative 10 squared. Minus 4 times a, which is a 1, times by c, which is a 10. And all of that was in a square root. And then we're going to take that and divide by 2 times a, where a is a 1. So simplifying that, these two negatives here, that's going to give me a positive 10. Then I'll have plus or minus. And then all of this inside the square root there, when you simplify that, you're going to get 60. And then on the bottom, 2 times 1, that just equals 2. Okay, and then this would be our answer, unless you know how to simplify this. So the root 60 you can actually simplify. So root 60, you could break 60 down into a 4 times a 15. So 4 times 15. And then the square root of 4 is a 2. So a 2 will be able to come out, but the 15 is going to be stuck inside. So let's just write that here. I had the 10 plus or minus, and then the 2 came out, but the 15 is going to be stuck inside the square root, and then all of that is being divided by 2. Now, if we have this divide by 2, the only time you can actually bring that up and divide it into both of these is if they are both divisible by 2. You can't just pick and choose one of them. It's got to be both or none. So in this case, both are divisible by 2. 10 divided by 2 is 5. And then 2 divided by 2 is 1. So I'm not even going to write the 1. I'm just going to write root 15. There's kind of a hidden 1 in front, but I'm not going to write it. So this is our answer as an exact value. To get the approximations as decimals, we can just take that and put it into our calculator. Take one where it's positive, take one where it's negative. And when you do that, when you take the positive one, you're going to get 8.87 and then some other decimals. And if you take the negative, you're going to get 1.12 and then some other decimals. And then rounding each of those to the nearest tenth, this one will give you 8.9 and the other one will give you 1.1. So those are our two answers, and that is the last question that we are going to be doing together. The rest you can work on your own.